Alright guys, so uh, in this video we want to talk about the examples that we had at the end of the book, not the end of the book of course, and the examples that we couldn't do in the class, the moment of gyration and until the end of the book. So right now we are starting with example 8.7, how to calculate the moment of gyration of this shape. So the question says, calculate the radius of gyration with respect to both centroidal axis of the cover plate W shape shown in figure 8.14. So as you can see, the I-beam that we have is W10 by 68. And if we go to Appendix A of the book, we have some numbers for this I-beam. And the numbers that we need right now are the area of this I-beam, which is 20 inches. D for this I-beam, which is 10.40 inches. BF for the I-beam, which is 10.13 inches. IX, moment of inertia in respect to axis X for this I-beam, which is 394 inches, and IY, which is 134 inches power 4. So all these numbers that we see in here, you should be able to see it in Appendix A. So you will be given these numbers in Appendix A of the book or in the exam. So BF is this area. So the base of our beam is BF, so which is 10.13 inch or 13 inch. And the T for this for the plates that we have on the sides of this I-beam is 0.75 inches. So first we need the moment of inertia of the whole thing. Since we have the moment of inertia of the I-beam, we have to calculate the moment of inertia of these two steel plates. So what I'm gonna do, I'm gonna just calculate the moment of inertia of each one. So and if we multiply it by 2, it's gonna be the moment of inertia for the both things. So Ix of my object, let me just write down the Ix and Iy calculation in here, so I know what calculations should I use. So I write down, if I want to calculate Ix of an object, which my object is this rectangular, I want to calculate the Ix of this rectangular. So Ix of the rectangular is 1/12 of BH3. Iy of a rectangular is 1/12 of HB3. So right now I'm trying to calculate the Ix of this object, Ix of O. So Ix of O is 1/12 of base. The base is 0.75 the height is, we have the height here, 10.40 inch cube, and y of my object is 1/12 of what's my height? 10.40, and my base cube 0.75 q. So if we calculate these two, we're gonna see that this is 70.3, just 4, and this is 0.36, just 4. And how much is the area of each two steels that I have on the other sides of the I-beam? So A equals 0.75 in the height, which is 10.40, 7.80 inches. So what do I need next? I need to know what's the moment of inertia of the whole thing. So what was my formula for moment of inertia of the whole thing? So again, the moment of inertia of the whole thing was, if I write down my formulas up here, so Ix was the sum of all my eyes of all the objects plus 82. So let's write it down. So my Ix equals, what was the Ix for each plate and what was the Ix for the whole thing? So Ix for the beam, we have it up here. So 394 inches plus, so we have 2 steel beams, 2. What was the Ix of each steel beams? So Ix is 70.3 inches plus, into, put it in bracket, 82. How much is my A? My A is this plus this, but just hold on a second. Since we want to see how much is Ix, this shape, the x-axis is exactly on the centroid of each part. So centroid of this part is here, centroid of this part is here, centroid of this part is here. So it is on the centroid, the moment of, if you want to calculate the moment of inertia of this part, the centroid is on the x-axis. So the d is going to be 0. If the d is 0, we don't need this part. So the answer is going to be 535, just 4. All right? Just one more time. If we want to calculate the moment of inertia of a shape, if it is symmetrical in all parts, in all shape, we don't need to use AD. But if it is not symmetrical, we have to use parallel axis theorem, which is this. Since the centroid of these three shapes are all in x-axis, so we don't need to know AD2 because D is 0, see, D is 0. So AD equals 0. We don't have to put it in this equation. But now, if we want to calculate IY, since the y's are different, if you can see the y's to the centroid of the object here, for example, the y of this part, the distance between the centroid of this part to this part is not 0, right? Is not 0. So we have to use parallel axis theorem. So IY equals sum of IOs plus AD2. So IY equals sum of IYs. So IY for the I is 134 plus, we have 2 steel beams, 2. How much was IY for each? So have 0.36. Okay. Now, AD2, we need to calculate the D, right? So, the D for this distance, the distance between the centroid of this part to this part, all right? So, as your book indicated, we can, this is 75, right? So, let me write it down with a different color. This is small part, so we are calculating this distance, which is 0.75 divided by 2 plus, now this distance, this distance. So the whole thing is 10.13. 10.13. So the half of it is what we need here. So the answer is gonna be 5.44 inches. Now we have our D. All right, so now we put the D in our calculation. Plus AD2. How much is our A? Here. 7.0. How much is our D? Our D was 5.4 inches. Just don't forget, we have 2 plates. So I actually had to write this down here, but never mind, that's fine. So the answer is gonna be, the final answer for IY is going to be 596 to the power of 4. So now we have IX and IY for the whole shape. Now we can calculate the radius of gyration. If you remember, the formula for radius of gyration was Rx equals Ix on A, the root. So how much was our, let's just write down Rx root. So how much was our Ix? 5, 3, 5, just to the 4. How much is our A? So our A is the area of the whole part. The area of each of these parts were here, 7.80. Let me just write this down somewhere here. So the area of the whole thing is, the area of our I-beam is 20 plus the area of these two plates, 2 of 7.80 inches. So the answer is 35.6 inches. So A is 35.6 inches to 35.6 inches. So the answer is going to be 3.88 inches, and Ry equals IY on A. So how much was our IY? The IY was right here, 596.4, and the A was 35.6, and the answer is 4092. So these are the final answers that our problem wanted. So if we go back to see what did our problem want, example 7.8. Calculate the radius of gyration with respect to both centroidal axes for the cover plated W shape shown in figure 8.14. So we have the radius of gyration to respect to y and respect to x-axis. So that's it. This was example 8.14. Okay guys, the next subject that we are going to talk about is the polar moment of inertia. As we already witnessed, the moment of inertia that we had so far was for x-axis and y-axis, like this. Y, x, for example, if we have something, if we have an object, if we have a beam that we want to know what's the moment of inertia of this object. So for example, this point, if we want to know what's the moment of inertia, so we gotta say, so this is gonna be the y of this point. This is gonna be the x of this point, as you can see. But if we have another axis, which is z, and if you want to know what's the moment of inertia compared to z axis, so this is gonna be the moment of inertia compared to z axis, the distance between here to z axis, which we call it r. As you can see in here, this is x, so xy, this is a right triangle, right? This is a right triangle. So if we want to see how much is r, as we have worked on it on chapter 2, r square equals x square plus y square. And J is our polar moment of inertia. J equals sum of a x square plus y square, or we can say sum of ax square plus sum of y ay square, and total J equals ix plus iy. So moment of inertia, or polar moment of inertia, equals moment of inertia compared to x-axis plus moment of inertia compared to y-axis. So if we go to the problems and examples of this part, the polar moment of inertia, the first example is example 8.8. It says calculate the polar moment of inertia for the hollow circular shaft with the outside diameter of 4 inches and the inside diameter of 3 inches, as shown in this picture. I'm not a good picture drawer, sorry. This is the shaft. All right. So if we go to table 3 at the end of the book for hollow shafts, we're gonna see that the equations for hollow shaft for moment of inertia, polar moment of inertia, is, let's write down our equations again here. JCG equals pi on 32 d to the 4 minus d 1 to the 4. So let's see what we have here. JCG equals pi 32. What's our d? D is the outside diameter. The outside diameter is 4 inch, 4 minus the inside diameter d1, which is 3 inch to the 4, and the answer is 17.18 to the 4. So this is the polar moment of inertia for this shaft. Okay team, let's go to example 8.9. For the T-shaped area shown in figure, calculate the centroidal moment of inertia, the radius of gyration, and the polar moment of inertia. So as we can see, we have some numbers: 10 inch, 2 inch, 10 inch up, and as we can see, we can split this shape to two shapes: shape A1, which is the top shape; shape A2, which is the bottom shape. And we all agree that this shape is symmetric compared to y-axis. See, if we see the y-axis, this shape is symmetric. But if we see the x-axis, can we say this shape is symmetric? No, it is not symmetric. So for calculating ix, we need d. For calculating iy, we don't need d. So let's calculate ix first. So for calculating ix, we need to know where is the centroid of the whole shape. And since you guys know that I love the table, I'm just gonna write down table. I'm just gonna draw the table for myself. Let me use the black pen for a change. So what do I have here? I have object 1, I can call it A1, or object 1. Let's call it object 1. Object 2. And what else do I have? I have the area for object 1, y for object 1, and ay. So object 1. What is the a for object 1? So 2, 10, 20. Object 2, 10 to 20. What is the y for object 1? So here to the centroid, which is 11, and from the base to centroid of the object 2, which is 5. So here, this is 10, half of it is 5, so my y2 is 5. And for object 1, this is 10, and half of 2, which is the centroid of this object, plus 10 is 11, right? So ay is 220, and for object 2 is 100, and the sum of this is 40, sum of this is 320. So where did I put my blue pen? So if I want to calculate the centroid of the whole object, I can write down y bar equals sum of ai on sum of a, the whole a. So 320 on 40 is 8 inch. So the centroid of this object is actually 8 inches. If we call this 5, so 8 should be almost here. So d1, the distance between centroid of A to my object, is 3 inches, and d2, the distance between centroid of object 2 to the centroid of the whole shape, is actually 3 inches too, right? Because this is 5, this is 8, so 3 inch, and this is 8, this is 11, 3 inch. All right, so we have D1, D2, and let's see how much is my I. Let's do it with this pen. So IX equals 1/12 of BH3. Sorry, I wanna know what's the I for each object, not IX, I of the objects. So for object number 1, IO1, which is 1/12 of, what is the base? Base is 10 inch. What's the height? The height for object number 1 is actually 2 inch. 2 inch. And IO2. So again, BH cube 1/12. What's my base for object number 2? My base is 2. And the height is actually 10 inch. The answer. So my answer for object number 1, sorry, this is cubed, this is cubed. So the answer for object number 1 is actually 6.67 inch, and for object number 2 is 166.7, just 4. So let's say this is I in moment of inertia for object number 1, and this is moment of inertia for object number 2. Now I have the both moment of inertias. Let's see what is the moment of inertia. So let me write down the main formula that we are going to use over here. So as you guys remember, the IX was the sum of all the I's, we can call them all the IOs, plus AD2, right? So let me write it down here. IX equals so sum of I1, which is 6.67 inches plus A. How much was the A? The area for object number 1, 20. And how much was D? D for object number 1 was 3 inch. 3, 2. Plus, because we want to see the sum, right? IO 166.7 inches plus A. What was the A? A area for object number 2 was 20 multiplied by, how much was the D for object number 2? So this is D for object number 2, 3 square. So the answer is 533 inches to the 4. Okay, now we have our IX. Just draw this for this as well. We have our IX. Let's see how much is our IY. Let me write it down with green. IY, as we all know, IY equals sum of IO plus AD2. So the thing is, because this item in this shape is symmetric in y-axis, we don't need AD2. We just need the sum of IYs. So how much is the sum of IYs? What's the sum? What is IY? As we know, we have two rectangulars, right? IX for rectangular. Let me just write it down with black as well. IX for the rectangular was 1/12 of BH cube right here. Okay, but IY for the rectangular was 1/12 of HB cube. So we have to know what's the IY for each object. So object number one. Object number one. So based on our formula, 1/12 of what's object number one's base? Object number one's, oh, sorry, H. What's object number one's height? 2. And what's object number one's base? 10. Q. And I, object number 2y equals 1/12 of what's the height? 10. And what's the base is 2q. And the answer for object number 1 and object number 2 are going to be the same answers, right? They look the same by consequence. So 7 inches to the 4, 166.7 inches to the 4. So we have our IYs. Now, based on our formula, IY, write it down with blue again. IY equals sum of IO. Since we don't have AD, because as I told you guys, it is symmetric in y-axis. So 166.7 plus 6.67 just to the 4, and the answer is 17. It is 3.3 inches to the 4. So now we calculated most of the things. So we have IY and we have IX. So if you want to calculate the radius of gyration, let me write it down with black this time. The radius of gyration was Rx equals root of Ix on A. So Rx equals root of, how much was our Ix? The Ix, where was it? Here, 500. 33. And how much was our A? The total of A is 40. So we have A1 and A2, 20, 20. The total is 40. So 40. The answer is 3.65 inches. And Ry equals root of Iy to A. Ry equals root of, much was our Iy, as 173.3 just to the 4, and divided by A, which is 40. Oh, that's difficult. What should I write down the answer? So the answer for Ry is gonna be 2.08 inches. I want to do all of it in one page, so I don't want to go to the next page. So, and the last part of the question was the polar moment of inertia. Polar moment of inertia, based on our formula, is JCG equals Ix plus Iy. So how much was our Ix? Is 533 just 4 plus 173 just to the 4 equals 706 just to the 4. And this is my polar moment of inertia. So A wanted the calculate the centroid of moment of inertia for Ix and Iy. So we calculated Ix and Iy, and B was the radius of gyration. This is the radius of gyration, Rx and Ry, and C was the polar moment of inertia, which is polar moment of inertia. All right, and this is the last example of this chapter. Example 8.10. 2C310 to 31 structures, steel channel shaped, are welded together at their flange tips as shown in this figure. Determine the radius of gyration and moment of inertia. So if you go to appendix C of the book, you're gonna see these numbers for this flange. I just draw it in different colors so you guys can see they are they both look the same, but they are different. So the area is 3,920 millimeters square. The base is 74. Let's just draw where is the base. So the distance between here to here is 74.7 millimeters, and the X bar is 17.7 millimeters. As you can see, it is symmetrical in x-axis, but in y-axis, if just think about the green shape or the red shape. In y-axis, you see it is not symmetrical. So the centroid of this shape is 17.7 millimeters from the y-bar, so it should be around here. So this distance is 17.7 millimeters. So let's make this area, if we want to see this area, how much it is. So simply this is going to be our d, because it is going to be the distance from our centroid to the y-axis, right? So d to the y-axis equals 74.7 millimeters minus 17.7 millimeters equals 57 millimeters. So this is going to be the distance between our centroid to the y-axis, which is 57 millimeters. Doesn't matter, it's from here to here, 57, and because they're both the same shape, structural steel channel. So what do we need right now? We need Ix. So for calculating, let me just write down my formula up here with black again. So Ix equals the sum of all the i's of all the objects plus AD squared, and IY equals sum of all my i's plus AD squared. So for Ix equals, what is the I for this shape? We already have it in appendix C. So the Ix is 53.7 and 10 to the 6 to the 4 plus y plus, because both two have the same Ix, right? So we multiply it by 2. The answer is going to be 107.4 and 10 to the 6 millimeter to the 4. So this is going to be our Ix. Since it is symmetric in x-axis, we don't need d, but it is different in Iy. So what was our Iy? The Iy was, since we have two of this shape, what is our Iy? Let me put it in bracket. 1.61 multiplied by 10 to the 6 meter 4, and we have because we have two shapes, right? How much was our A? 3,920 meters by how much was our D? D was 57, right here. 57 meters square. So the answer, put it in bracket, the answer is 28.7 10 to the power of 6 meter 4. So we didn't need Ix and Iy. The question didn't ask for Ix and Iy. The question actually asked for the radius of gyration, the least radius of gyration. But for the radius of gyration, And for polar moment of inertia, we actually need Ix and Iy. So for radius of gyration, because the question asks what will be the least of radius of gyration, and x-axis is the weakest axis, right? As you can see in the question here. So which number is bigger? This number is weaker, right? And as we talked about it, if the number is up, if the number is high, the moment of inertia is better. So to the strength for bending or buckling is going to be more. But this is the weakest. This is the weaker axis. So we got to see what is the radius of gyration in this axis. So what was our, let me just write it down with different color. What was our y equals the root of Iy to a. So our y equals the root of, how much was our Iy? 28.7 and 10 to the 6. How much was our I? This is our I, which is given to us by the question. 3920 to the power of, not to the power of some, sorry, but something is missing here, which is because we have two areas, so we have two I's, right? So it is two A's, sorry. So A means the area for both. So this is this is the area for one, so we need area for two. The answer is gonna be 60.5 millimeter. This is gonna be the radius of gyration. And if we want to calculate the polar moment of inertia, let's just write it down with different color. J equals Ix plus Iy. Oh, gotta see a big number. So let's see. J equals 7.4 to the power of 6 meter plus this number 28.7 10 to the 6 4. The answer is, oh boy, it's a big number, 136.1 10 to the 6 meter 4. So this is gonna be our final answer for A and final answer for B. All right, guys, this is the end of chapter 8. If you guys have any question, have any concern, please put it in Q&A and I should be able to answer you guys promptly. Thank you.
یعنی خود خری، نه اینکه مثل خری. اصلا مصدری، معنی مصدری میده. خر بودن تویی. تجسس، اصلا خر رو تو